Hello friends and my dear students, I welcome you all to my channel. If you are watching my videos regularly and if you are not yet subscribed, then I will highly suggest and request that you kindly support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of my playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. This is part 2 on the chapter linear equations in one variable. If you have not watched the part 1 on this chapter, which is the previous video, then I highly suggest you that you please first watch that video to get a good background of what is the linear equation is and what do we mean by a solution of a linear equation. So in this video I will discuss about how we solve a linear equation using the rules for solving an equation and the concept of transposition of terms. And finally we will solve some selected problems from the textbook of author RS Aggarwal from the exercise 7a. So let's get started. Okay, so as usual I have my rough notes on the left hand side and I will solve and discuss on the right hand side. So in this video we will be discussing about how we solve a linear equation. In the previous video we have already understood what is a linear equation. So a linear equation is nothing. A linear equation is let me give you a very brief of what we discussed in the previous video. So a linear equation is nothing but is of the form LHS equals to RHS, where both LHS and RHS are a linear polynomial. So I am in short writing linear polynomial. They are both linear polynomial. And what is a linear polynomial? A polynomial with degree 1. Polynomial with the degree 1 is known as a linear polynomial. So if you have both the LHS and RHS are linear polynomial, and in between we have the equality sign. So this is a equation. This is a linear equation. This is a linear equation. And since we are we will be studying only linear equation of one variable. So the linear polynomial, both LHS and RHS will have a single variable. Now let's try to understand how we solve a given linear equation. So there are some rules. And finally the transposition rules. So let's understand what are the rules. So the rule says that you can add or subtract a same non-zero number to both sides, that is to both the LHS and RHS. That will not make any difference to the linear equation. That is, the linear equation will remain the same. For example, you can see in the notes for the equation 2x minus 1 equals to 4, we can add to both sides 1. So we get 2x minus 1 plus 1 equals to 4 plus 1. And the LHS then becomes 2x and the RHS becomes 5. So the equation becomes 2x plus equals to 5. So in this case we added 1 to both the sides, that is to both LHS and RHS. You can see the second example. The given equation is 9x plus 5 equals 23. So here we subtracted 5 from both the LHS and RHS. So then the equation becomes 9x plus 5 minus 5 equals 23 minus 5. And that is when we simplify that, it becomes 9x equals 18. So in this, so you can add the same non-zero number to both LHS and RHS, and the linear equation remains the same. The linear equation is not, the equality is not affected. The equality remains the same. The other rules is about that you can multiply or divide the same non-zero number to both LHS and RHS. This is a very frequently used rule while solving an equation. So this is more important than the addition and subtraction of same non-zero numbers. So in this rule, let's take the example. First example, we have the equation 3x by 4 equals to 2. Now we can multiply both sides, both LHS and RHS, by the number 4 by 3. So we get 3x by 4 into 4 by 3 equals 2 into 4 by 3, and the LHS then becomes x and the RHS then becomes 8 by 3. So we now have x equals to 8 by 3. So in the equation we have multiplied both sides, LHS and RHS, by 4 with 4 by 3. In the second example, you see the equation is 9x equals 3. Now we can divide both the LHS and RHS by 9, and we get 9x by 9 equals 3 by 9, which implies x equals 1 by 3. Another example, the third one, is that we have the equation x minus 1 by 2 plus x minus 3 by 3 equals half. Now we are multiplying both the LHS and the RHS by the number 6. Now why number 6, that we will discuss while solving problems. So we are multiplying both the LHS and RHS by the number 6. So we get 3x after multiplying both the LHS and RHS by 6. The LHS becomes 3 into x minus 1 plus 2 into x minus 3, and the RHS becomes 3. 6 multiplied by half is 3. So the equation then becomes 3 into x minus 1 plus 2 into x minus 3 equals to 3. So these were the rules of addition, subtraction, and multiplication and division by the same number to both the LHS and RHS of a given equation. We can do that, and that will not change the equality. The equality will still hold. Okay. And the next rule is, which is very, very important, this rule will be frequently used, is the transposition of terms. It says that any term in the equation can be moved from one side to the other. By side it means LHS or RHS. So any term can be moved from one side to the other with change of its sign. So in the first example, you see the equation given was minus x plus 1 equals to x minus 3. So now if we move the term x from the RHS to the LHS, it becomes minus x plus 1 minus x equals minus 3. Now when we moved x from the right hand side, the term x on the from the right hand side, the term was x, and when we will move it to the left hand side, it will become minus x. That is the reason in the LHS becomes minus x plus 1 minus x equals minus 3. Similarly, in the second example, the equation was 2x minus 3 equals to 2. And if we move the constant term minus 3 from the LHS to the RHS, it becomes 2x equals to 2 plus 3. So the constant term was minus 3 in the LHS, and when we moved to the RHS, it became positive 3. Now what actually is happening is that, so let's say you have an equation of the form, let's say 3 by 2 x minus any constant term, let's say 9, equals to, let's say, x plus 1. I am taking a very simple basic example. This is an equation. When you move a term either from the left hand side to the right hand side or from the right hand side to the left hand side, what actually you do is that, let's say we want to move the term x from the right hand side, this one we want to move it to the left hand side. Now when we move the term x from the RHS, it will be gone from the RHS, it will be removed from the RHS, but what will be added to the LHS? The term that will get added to the LHS is the additive inverse of x. So when you are moving the term x to the LHS, add additive. You know what is an additive inverse of a number? It is, we just change the sign, additive inverse of x. So additive inverse, I am in short writing AI. So AI of any number, let's say AI of let's say a is a number, any number, it could be an integer or fraction, decimal, whatever. AI of a is nothing but you just put a negative sign in front of the number. So when you put a negative sign in front of any number, the sign changes. Similarly, it is also same for terms or variables. AI of x equals minus x. So the term on the right hand side was x. So when you move it to the left hand side, you will just add the additive inverse of x to the left hand side. So then after moving, it becomes 3 by 2 x minus 9 minus, actually it is minus x. We are adding the additive inverse of x. What is x? X is the term that we are moving from the right hand side to the left hand side. So this is x is gone from the right hand side, 1. Now this is nothing but 3 by 2 x minus 9 minus x equals 1. Now the same thing happens. Let's say, okay, let's take another example. Let's say we have 4x plus 1 equals, let's say, minus x plus 2. This is the given equation. Now if we open the brackets, if we open the symbol, grouping symbols, brackets from the RHS, it becomes 4x plus 1 equals minus x minus 2. Now we want to transpose the term minus x from the RHS to LHS. When we transpose by this arrow mark, I mean we are transposing the term minus x to the from RHS to LHS. So what will happen? Additive inverse of minus x, additive inverse of x, additive inverse of x, add additive inverse of x over here, this will be minus x. Now so in this case, additive inverse of the term is minus x. So additive inverse of minus x, AI additive inverse of minus x is minus of minus x, and we know this is x. So add x to LHS. So this implies it will become, the equation will become 4x plus 1 plus x equals, and the minus x term from the RHS will be gone. This is minus 2. So this is how we transpose terms from one side to other and the sign gets changes. I have explained transposition of terms from RHS to LHS. It will be the same when you transpose from LHS to RHS. Let me quickly show an example. Let's say we have 2x minus 2 equals 3. Now if we want to transpose this to the RHS, we will add 2 to RHS, and this will become 2x equals 3 plus 2. So this was transposition of a term from the LHS to RHS. So this is transposition. Now always remember that, so these are the rules that will be used while solving a linear equation in one variable. Now the ultimate task or the objective while solving a linear equation is to bring all the terms with the variables to the left hand side and to bring all the terms, constant terms, to the right hand side. So the primary task, please follow the notes, the primary task in solving a linear equation is bring all the terms with the variable to the LHS. So let me give you an example. So let's say we have an equation x minus 1 equals minus x plus 3. I'm just taking a random example. So it is saying bring all the terms with the variable to the LHS. Now both LHS and RHS may have terms with variables. You bring all the variable terms with the variables to the left hand side. So by doing so, bringing all the variable terms to the LHS, I get x minus 1 plus x equals 3. So I moved the minus x term from the RHS to the LHS. This is this. Now next is, it's saying bring all the constant terms to the RHS. Now both the LHS and RHS may have will have not both, either one or both will have some constant terms. You bring all the constant terms to the RHS, to the right hand side. So in this example, I will move the constant term minus 1 from the LHS to the RHS, and I will get x plus x equals, while moving minus x to the RHS, its sign will change. So it will be 3 plus 1. So now it is saying, the third rule, the third point saying add all the terms of variables in the LHS and RHS. Now you have to add all the, so in after this the LHS will be all terms having the variables x or some other variables. It could be named some other letters like x, y, z, and also the RHS will have either the one or more constant terms. So the next step is you add up all the variable terms in the LHS. So this becomes, in this example, 2x, and you add up all the constant terms in the RHS, and it becomes, in this example, 4. So finally you will get the equation in the form, in this example, 2x equals to 4, and in the notes it is saying that finally we will have to solve the equation k1x equals to k2, where k1 and k2 are both constants. They will be constants. Constant means any fixed number, integers or fractions or decimals, whatever. So this is the final form we will get, and from this we have to solve x. It is nothing but this implies that I can now multiply both sides by half, and I will get x equals to 4 into half, that is 2. Or simply we say that, from here we say that x equals to 4 by 2, that is 2. Okay. So that was all about the concepts and the theory and the logic behind how do we solve a linear equation in one variable. Now let's try to apply this in solving some problems from the exercise 7a. Now while solving these examples, I will follow two methods. The first method is that I will bring all the x terms to the left hand side. I will simply bring all the x terms. I will gather all the x terms to the left hand side, and I will gather all the constant terms to the right hand side, and I will then add up all the sum up all the variable terms in the LHS and sum up all the constant terms in the RHS. That is one way of doing. And another way of doing is that instead of doing that, you might have to do some manipulation, like multiplying the LHS and the RHS by some number, or dividing some number. Whichever method you find convenient, you can choose that method. Now, okay, so let's start solving the problems. So the problem number 3 is very straightforward. We have 7 minus 5x equals to 5 minus 7x. In the first method, this method is straightforward. There is no alternate method. So what I will do is, we will try to bring all the x terms to the left hand side. So first let's bring all the x terms to the left hand side. So this implies 7 minus 5x. I am transposing the minus 7x term from the RHS to the LHS. So I will add, its sign will change, that is, it will become 7x. So 7x will be added to LHS and it will be removed from the RHS. Okay. Now I will bring all the constant terms to the RHS. I see there is a constant term 7 in the LHS. I will bring it to the RHS and its sign will change. So this becomes minus 5x plus 7x equals 5 plus minus 7, that is 5 minus 7. This is okay. So now, as per the points 1, 2, 3, 4 in the notes, now I will add up all the variable terms in the LHS and all the constant terms in the RHS, and we get minus 5x plus 7x is 2x, and the right hand side becomes minus 2. Now from here we got the form k1x equals to k2. So this is nothing, from here we can easily say that x is nothing but minus 2 divided by 2. Now actually what is happening behind the scene is that we are multiplying both the sides LHS and RHS by half. So if you do that, so now okay, so from here we usually directly say that x equals to minus 2 by 2. This is nothing but minus 1. But as a side note, from 2x equals to minus 2, what actually we are doing is we are multiplying both the LHS and RHS by half. You can also think it like this. Now the LHS, so 2x multiplied by half is x, and minus 2 multiplied by half is minus 1. So minus 1 is the solution of this equation. Now in problems you might also be asked to check whether the solution you got is correct or not. So how do you check it? You just put the value, the solution you got. By solution we mean the value of x that you got after solving. So if we put we got the solution as minus 1. Now if we put minus 1 in the given equation, and if we get the same value of LHS and RHS, then it is verified that our solution is correct. So let me do it for one problem. I will not do it for the rest of the problems. So check the solution. LHS when x equals to minus 1 equals to 7 minus 5 into minus 1. This is 7 minus, this becomes 7 plus 5. This is 12. And let's see what is RHS. RHS, x equals to minus 1 equals 5 minus 7 into minus 1. This is also 5 plus 7 equals to 12. So LHS equals to RHS equals to LHS. So our solution x equals to minus 1 is correct. Okay. Let's all see the question number 5. Question number 5 is also very straightforward, but first you have to do the multiplication. That is, you have to multiply 2 with the binomial x minus 2. You have to first do the multiplication. So this implies, from here we can say, so in a given equation you may not be immediately see the x terms, the variable terms. You might have to do some multiplication and division. So in this case we have to first do the multiplication of 2 into x minus 2. That is, we know, we have already studied, this is a product of a monomial. 2 is a monomial and x minus 2 is a binomial. So we know how to multiply a monomial and a binomial. This we studied in the algebraic expression by using the distributive law of multiplication over subtraction. So this is nothing but 2x minus 4, and the second one becomes 12x minus 3 equals 0. Okay. Now we will try to keep the variable terms to the left hand side and all the constant terms to the right hand side. So the variable terms are already, all the variable terms are already in the left hand side. So we will keep it like that, 2x plus 12x, but we will transpose all the constant terms from the LHS to the RHS. So if we transpose the constant term minus 4 to the RHS, we will add the minus 4 we will add its additive inverse, that is 4 to the RHS, and when we transpose the constant term minus 3 to the RHS, we will add 3 to the RHS. This becomes, now we add up all the terms in the LHS and RHS, that is add up all the variable terms in the LHS and add up all the constant terms in the RHS. We get 2x plus 12x is 14x equals 7. So you see, every time finally we will get an equation of the form some constant into x equals some constant. So from here we can say that x is 7 by 14. So basically in the notes you see that the final equation, the final form of the equation, after doing all these simplification and bringing all the variable terms to the LHS and all the constant terms to the RHS, it will be of the form k1x equals k2x, where k1 and k2 are constants, they are constants, fixed numbers. So from here we will say that x equals k2 by k1, and do not worry that k1 and k1 will never be 0. K1 will never be 0. So from here we can say that x equals to k2 by k1. So in this problem number 5, we can say from 14x equals to 7, we can say that x equals to 7 by 14. This is nothing but half. So I will not be doing the check, that is if the solution is correct or not. I hope it is correct. Okay, now this is the straightforward way of solving the equation. There is no, I don't think there is any other better alternative or some other alternative. So while I am solving the problems, you can pause the video and take a screenshot for your reference. Let's see problem number 7. Now here, until now you can see all the terms were involved with variables or integers. So there were no fractions or decimals. So that was easy. Now in the question number 7, we see some constant fractions, that is minus 1 by 3 and 1 by 5. Now the first method for me will always be to bring all the straight away to bring all the x terms to the LHS and bring all the constant terms to the RHS, and while you add the the terms with the variables, take their constants can be integer or their constants can be fractions. In this problem number 7, both the constants, both the coefficient of the terms 2x and x, they are integers. So it is easy. So the first method that I will not prefer, the first method will always be to bring all the x terms to the LHS and bring all the constant terms to the RHS straight away. So I will partition this space so that I will for some problems I will first solve it in the usual way, the straight away way, and on the right hand side I will show any alternative method that could suit you based on how comfortable you are with the addition and subtraction of fractions or decimals. So I will bring all the x terms to the left hand side. So this will become, if I bring the minus x to the LHS, it becomes 2x plus x equals, if I bring the minus 1 by 3 from LHS to the RHS, it becomes 1 by 5 plus 1 by 3. Now I will add up the terms in the LHS and RHS. It becomes 3x equals 1 by 5 plus 1 by 3. Now here we are dealing with fractions, we have to add fractions. Now in this method you have to be very comfortable in doing addition and subtraction of fractions or decimals. So 1 by 5 plus 1 by 3, we know that it will be 3 plus 5 by 15. So we have to take the LCM of 5 and 3. So this is 8 by 15. This is 8 by 15. So we got 3x equals to 8 by 15, and we know from here that x, it will be 8 by 15 divided by 3, that is multiplied by 1 by 3, that is 8 by 45 is the solution. Okay, now let's see what could be an alternative method which might suit you if you are not familiar, if you are not comfortable in doing addition and subtraction of fractions or decimals. So in this case we see that there are two fractions and they are both constant terms, so minus 1 by 3 and minus 1 by 3 in the LHS and 1 by 5 in the RHS. So what do you do if you only want to deal with integers? The terms will be variables that has an integer coefficient, and all the constant terms will also be integers. Then what you can do is, you see the denominator of all the fractions. In this example it is 3 and 5. You multiply, you find the LCM of 3 and 5, which is 15. Short writing, LCM of 3 and 5 is 15. Now multiply both sides, by 15. This will eliminate the fraction. So if I multiply both sides by 15, I get 15 multiplied by the LHS, that is 2x minus 1 by 3, equals 15 multiplied by RHS, that is 1 by 5 minus x. This implies if I do the multiplication in the LHS and RHS, the LHS becomes 30x minus 5 equals, the RHS becomes, after multiplication, after doing the product of 15 and the binomial 1 by 5 minus x, it becomes 3 minus 15x. So now we see all the terms, the constant terms are integers, and all the coefficients of the variable terms are also integers. So now from here onwards so this was a little extra work we did to deal with all the terms, to make all the terms either constant, all the constant terms integers, and all the terms, variable terms, to have integer coefficient. This extra work you will only do if you are not comfortable with addition and subtraction or doing arithmetic of fractions or decimals. So now we will bring all the x terms to the left hand side and all the constant terms to the right hand side. That will make the equation 30x plus 15x equals 3 plus 5. This implies if I add up the terms in the LHS and RHS, it becomes 45x equals 8, and this implies, now we know that x equals to 8 by 45. So we got the same solution. Okay, so the method on the left hand side is the straightforward method, where I will bring all the variable terms with the variable to the left hand side and all the constant terms to the right hand side. Then I will add up whatever the coefficient of the variable terms be, whether the integer or rational or fraction. I will have to then add all those variable terms. So in that case I might have to deal with addition and subtraction of fractions or decimals, and I have to be comfortable in that, in following the method of solving in the left hand side. And if you are not comfortable in doing arithmetic of addition and subtraction of fractions or decimals, then you will locate the fraction part, and you will find the LCM of all the denominators of all the fractions, and by that LCM you will multiply both the RHS and LHS. That will make the equation in a form where all the terms, constant terms, will be integers, and all the coefficient of the variable terms will also be integers. Now let's see the problem number 8. It also has fractional part. See, x by 2 in the LHS and x by 3 in the RHS. Let me first do it the standard way, that is straightforward way, where I will bring all the x terms all the variable terms to the left hand side and all the constant terms to the right hand side. So if I do that in this example, it becomes x by 2 minus x by 3 equals 5 plus 3. Now I will add up the terms in the LHS and RHS. Now x minus 2 minus x by 3, we know I know that it is x into half minus 1 by 3 minus 1 by 3. This is equals to 8. So now I have to see that I have to do subtraction of rationals, subtraction of rational numbers, and I have to be comfortable with that. Now this implies now half minus 1 by 3 is nothing but 1 by 6. So this becomes 1 by 6 into x equals to 8, and this implies, remember that x equals to 8 divided by 1 by 6, which is nothing but 8 into 6, that is 48. So let me check once again if I did it correctly or not. Half minus 1 by 3 is 1 by 6, fine. 1 by 6 is 8, yeah, it is fine. So from x by 6 equals to 8, I know that to get x, I have to divide. From this step, this is of the form k1x equals to k2, and from here we know that x equals to k2 by k1. This concept I have applied. So x equals to 8 divided by 1 by 6. In this example, k1 is 1 by 6. Okay. Sorry, let me remove this one because I have to solve the alternate method. Now, as an alternate method, since there is fraction or rational x by 2 and x by 3, if you want to eliminate that, if you don't want to work with the addition and subtraction of rational numbers or fractions, then what we will do is, so we see that the rational terms, that is x by 2 and x by 3, have the denominators 2 and 3. So else we will find the LCM of 2 and 3, it is 6. So we will multiply both sides by 6. So this implies 6 multiplied by the LHS is x by 2 minus 3, and 6 multiplied by the RHS is 5 plus x by 3. Now if we do the products on the to the both sides, this becomes 6, this becomes 3x minus 18 equals 30 plus 2x. Okay, now I will bring all the variable terms to the left hand side and all the constant terms to the right hand side. So after doing that, it takes the form 3x minus 2x equals to 30 plus 18. Now if I add up all the terms in the LHS and RHS, I get x equals to 48. So we got the same solution. 48 is the solution. Okay. Let's see the question number 12. Okay. So in the straightforward way, what I will do is I will bring now, in some cases, in while solving the equation in the straightforward way, that is the way I am solving in the left hand side, you might have to simplify the given equation so that you get all the you have to separate out all the variable terms. Now in this equation 2m plus 5 by 3, you have to separate out the variable term and the constant term. So we know that this is nothing but 2m by 3 plus 5 by 3, and the RHS is 3m minus 10. This is what I was trying to say by you have to simplify some expressions. So 2m plus 5 by 3 is nothing but 2m by 3 plus 5 by 3. I hope you understood this. The concept is a plus b by c, where a, b and c are numbers. Obviously c is a non-zero number, is nothing but a by c plus b by c. Similarly, a minus b by c is nothing but a by c minus b by c. So this is the concept I applied to simplify the term 2m plus 5 by 3. Okay. Now I will bring all the variable terms to the left hand side and all the constant terms to the right hand side. So this becomes 2m by 3 minus 3m equals minus 10 minus 5 by 3. Now I have to add all the variable terms in the LHS and all the constant terms in the RHS. In this problem, if you are not comfortable, now I know that this is nothing but if I m into 2 by 3 minus 3, and the LH and the RHS, we can say, we can take negative component 10 plus 5 by 3. Now for this problem, if you are not comfortable with doing addition and subtraction of rational numbers, then it will be time consuming for you, or it will be difficult for you. So in that case, you will have to you can follow the method on the right hand side that I will shortly solve. So now this, for the solving, we have to simplify 2 by 3 minus 3, which is nothing but minus 9 minus 7 by 3. So this is m into minus 7 by 3, and on the right hand side 10 plus 5 by 3, 10 plus 5 by 3 is 35 by 3. Let me check by 3. Okay. Now this implies what is m? M will be, as said, minus 35 by 3 divided by minus 7 by 3, which is nothing but multiplied by 3 by minus 7. Now if we simplify, minus 35 by 3 multiplied by 3 by minus 7, minus cancels out, 3 cancels out, 7 divides 35 by 5. So the answer is 5. Answer is 5. M is 5. The solution is 5. Okay. The same thing. Since this equation has a rational term, that is the 2m plus 5 by 3, what we will do is to get rid of the rational terms, or to transform the equation so that every constant term is an integer and every variable term has a coefficient of integer. We will multiply both sides by 3. Since the only rational term we can see is 2m plus 5 by 3 and it has a denominator 3. So we will multiply both sides by 3. So we get 3 into the LHS is 2m plus 5 by 3 equals 3 into RHS is 3m minus 10. Now this implies if you do the product on the LHS, it becomes 3 cancels out, so 2m plus 5 equals, if you do the product on the in the RHS, it becomes 9m minus 30. Now we will bring we see that all the constant terms are integers and all the variable terms have coefficient as integers. Now we will bring all the variable terms to the left hand side and all the constant terms to the right hand side. So it becomes 2m minus 9m equals minus 30 minus 5. Now this implies if we do the addition of the variable terms and the addition of the constant terms, we get minus 7m equals minus 35. From here we say that m equals minus 35 divided by minus 7. Minus minus cancels out, 7 divides 35 by 5, so the answer is 5. Solution is 5. Okay. Let's do question number 13. It's a little complex equation. It is not actually it is looking complex because of the products, but there is so the only way we can, not only way, the straightforward way we can only, the straightforward way is to do the products and then bring all the variable terms to the left hand side and all the constant terms to the right hand side. There is no rational part, there is no rational terms or fractional terms that we have to find the LCM and do some kind of multiplication to both sides. That is not required in this problem. So we have to do the products and bring the constant terms and the variable terms, bring the variable terms to the LHS and bring the constant terms to the RHS very slowly and carefully. So the only thing is that you have to do the multiplications and the transpositions very carefully, and so that you do not make any silly mistake. So if I do the products, so this becomes, if I do the product of 6 multiplied by 3x plus 2, it becomes 18x plus 12. And if I do the product of minus 5 into 6x minus 1, it becomes minus 30x plus 5. This is LHS, and the RHS is 3x. 3 multiplied by x minus 8 is 3x minus 24, and minus 5 multiplied by 7x minus 6 is minus 35x plus 30, and we have the remaining term, that is 9x. So now I will bring all the variable terms to the left hand side and all the constant terms to the right hand side. So by doing so, it becomes 8x minus 30x. I will bring the minus 3x plus 35x minus 9x equals, I will bring all the constant terms to the right hand side, that is and the right hand side becomes minus 24 plus 30 and minus 12 and minus 5. Okay. Now if I do the add up all the variable terms and add up all the constant terms, I get 18 minus 30 minus 3 plus 35 minus 9 x equals, how much is the RHS? Minus 24 plus 30 is plus 6, 6 minus 12 is minus 6, and minus 6 minus 5 is minus 11. Now I have to find the coefficient of x, that is do the simplification of the integers, addition and subtraction. So minus 30 minus 3 plus 35, this total becomes 2, and 18 plus 2 is 20, and 20 minus 9 is 11. So I have 11. 11x equals minus 11. This implies x equals minus 11 by 11. This is minus 1 is the answer. So there is no alternative method for solving this equation. This is straightforward. You just have to do the product, simplify the given equations, do the products carefully, and bring the all the variable terms to the left hand side and bring all the constant terms to the right hand side, and then do the addition of the variable terms and the addition of the constant terms carefully. Now see, let's see question number 18. Now here also we see in this problem there are some terms which are rational. There are two terms rational, one y minus 1 by 3 and minus y minus 2 by 4. These are the two rational terms. Now in the straightforward way, what I will do is I will simplify the given equation so that I can separate out all the variable terms and the constant terms. So this is nothing but y by 3 minus y 1 by 3 minus y by 4 and plus 2 by 4. Remember that it's better to so why it is plus 2 by 4, because we have a negative sign in front of the term y minus 2 by 4. So if you put a grouping symbol, that will make it more readable and easy. Now you can see that if you remove the second grouping symbol, you will have to change the sign of all its terms. So the inside the second grouping symbol, the terms were y by 4 and minus 2 by 4. So when you remove the grouping symbol, second grouping symbol, the terms, the sign will change. So it will become minus y by 4 and plus 2 by 4. Okay. Now this was the LHS and the RHS is 1. Okay. Now I will bring do transposition of terms so that all the variable terms are in the left hand side and all the constant terms are on the right hand side. So this becomes y by 3 minus y by 4 equals 1 plus 1 by 3 minus 2 by 4. Now I will add up all the variable terms in the LHS and all the constant terms in the RHS. That will become y minus 3 minus y by 4 is nothing but y by 12. This equals 1 plus 1 by 3 minus 2 by 4. This is nothing but if I do the LCM of this is addition and subtraction of rational numbers. So this will become 12 plus 4 minus 6 by 12. I hope I did it right. The LCM is 12, so 12 plus 4 minus 6. Okay, so this implies y by 12 equals, the right hand side becomes 12 plus 8, 12 plus 4 is 16, 16 minus 6 is 10, so 10 by 12. Now from here we say that y, this is y by 12 is nothing but 1 by 12 into y equals 10 by 12. Now this implies y equals to 10 by 12 divided by 1 by 12. Now we know that a divided by b for numbers a and b, where b is a non-zero number, we know that a divided by b is nothing but a multiplied by reciprocal of b, that is 1 by b. So we have to find y, we have to divide 10 by 12 by 1 by 12. So dividing by 1 by 12 is nothing but multiplying with 12. So this is 12. This is nothing but 10. So the solution is 10. So this was the straightforward way where we separate out all the variable terms and then we collect all the variable terms to the left hand side and all the constant terms to the right hand side. But in this method we have to deal with addition and subtraction of rational numbers or fractions or decimals. Now the alternate method, if you do not want to deal with addition and subtraction of rational numbers or decimals, what you can do is, we see that the terms having in the form of rational form, that is fraction, it is in the form of a fraction or rational number. We see the terms are y minus 1 by 3 and y minus 2 by 4, and the denominators are 3 and 4. So we will first find the LCM of the denominators, that is 3 and 4, which is 12, and then we will multiply both the LHS LHS and the RHS by the LCM to both sides, multiplying by 12 to both sides. This makes the equation as 12. The LHS was y minus 1 by 3 minus y minus 2 by 4, and the RHS was 1. So if you multiply by 12, it is 12. Now if we do the product, in the LHS, it becomes 12 into y minus 1 by 3 minus 12 into y minus 2 by 4 equals 12. Now this implies 3 divides 12 by 4, so this becomes 4 into y minus 1 minus 3 into y minus 2 equals 12. This implies, if we do the product again, 4y minus 4 minus 3y plus 6 equals 12. So we have transformed the equation in a form where all the constant terms are integers and all the variable terms have coefficient integers. So now we will gather all the variable terms to the left hand side and all the constant terms to the right hand side. This makes the equation 4y minus 3y equals 12 plus 4 minus 6. This implies, if we add up the variable terms in the LHS and add up the constant terms in the RHS, this becomes y equals 12 plus 4 is 16 minus 6 is 10. So the solution is 10. Okay. Problem number 23 is also similar to 18, but let's do it anyway so that you have a good understanding. Okay. So the usual way, in the straightforward way, I will try to simplify the given equation so that I can clearly see, separate out the variable terms and the constant terms. So 2x minus 3 by 5 is nothing but 2x by 5 minus 3 by 5, and x minus 3 by 4 is nothing but x by 4 minus 3 by 4, and the right hand side 4x plus 1 by 7 is nothing but 4x by 7 plus 1 by 7. Now I will bring all the variable terms to the left hand side and all the constant terms to the right hand side. So it becomes 2x by 5 plus x by 4 minus 4x by 7 equals 1 by 7 plus 3 by 5 plus 3 by 4. So as you can see, now you will have to deal with addition and subtraction of rational numbers, and you have to be comfortable with that. Only if you are comfortable, then you can use this method, straightforward method. So now this implies, if I add up all the variable terms in the LHS and add up all the constant terms in the RHS, it becomes 2 by 5 plus 1 by 4 minus 4 by 7 x equals, now I have to add all these rational numbers. We have to find the LCM of 7, 5 and 4, which is 35 and 70, I guess 70. Yeah, it is 70. So it will be 20 plus 20 plus 28 into 3, 28 into 3 plus 3 into 35 by 70. And also the LHS becomes, the LCM will also be 70, and it will be 2 into 28 plus 35 minus 4 into 20 by 70 equals, now if we this is a long computation, but anyway we have to do it. So this is 20, this is 20 plus 28 into 3 is 24, 84 I guess, and 35 into 3 is 105 divided by 70. Also the LHS, if we simplify it, it becomes 56 plus 35 minus 80 divided by 70, and the RHS becomes 20 plus 84 is 104, and 104 plus 105 is 209 by 70, and this implies, if we further simplify the LHS, it is 80 and 91 minus 80 is 91 minus 80 is 11 by 70 equals 209x. Sorry, there was an x in the LHS. This is x. So 11x by 70 is 209 by 70. This implies x equals 209 by 70 divided by 11 by 70, which means multiplied by 70 by 11. Now 70 cancels out. Now 11 does it divide 209? So 1 and 99, yes, 19. So x is 19. It was a little long computation with integers and a little bit of lengthy, but anyway you have to do this. Now the other way, the alternate way is we have to find, we see all the three terms, I mean in the equation we have the denominators 5, 4 and 7. So we have to find the LCM of 5, 4 and 7, which is 20 and 140. What is the LCM of 5, 4 and 7? Is it 70? Is it 70? No. What I am doing, what is the LCM of 5, 4 and 7? How do we find the LCM of numbers? So we first divide by the lowest prime, lowest prime numbers that divides at least two of this. If these divide by 2, this is 5, this is 2, 7, this is 2, 5, 1, 7, this is 5, 1, 7, and this is 7, 1, 1. So 35, 70, 140. 140 is the LCM. The 140 is the LCM, not 70. So I did it wrong. Anyway, so 140. Okay, so 140 is the LCM of 547 is 140. Yes, 140. So if we, let me first complete the alternate method, then I will try to fix the method, fix the error that I did in finding the LCM in the left hand side. That is a straightforward method. The LCM I wrote as 70, but it will be 140. So LCM is 140. Now multiplying both sides by 140, we get so 140 multiplied, the LHS is 2x minus 3 by 5 plus x minus 3 by 4, and the RHS we have to multiply it by 40 into 4x plus 1 by 7. So we have this equation. So this implies if we do the products on the both sides, if you multiply 140 with the LHS, it becomes 140 divided by 5 is 24. It's 28. Is 28. 28 into 2x minus 3 plus 140 divided by 4 is 35 multiplied by x minus 3 equals, we have to do the product of 140 with the RHS, that is 20 into 4x plus 1. Now again we have to do the product of 28. If we simplify the LHS, it becomes 28 multiplied by 2x minus 3 is 56 x minus 84 plus 35x minus 105 equals 80x plus 20. Now if we bring all the x terms, variable terms, to the left hand side and all the constant terms to the right hand side, it becomes 56x plus 35x minus 80x equals 20 plus 84 plus 105. Now if we add up all the terms, variable terms in the LHS, and add up all the constant terms to the RHS, it becomes 56 plus 35 minus 80x equals 20 plus 84 is 104, and this is 209. Now this implies 56 plus 35. 56 plus 35 is 91, and 91 minus 80 is 91 minus 80 is 11. So 11x equals to 209. This implies x equals to 209 divided by 11. That was coming out to be 19. So we got the same result as the result we got while solving it in the straightforward method, but in the straightforward method we took the LCM of 547 as 70, which is wrong. So 70. This should not be actually 70. This should be 140. Now even even if considering the LCM as 70, we got the answer 19. I have no idea why. Anyway, I am not fixing this. The LCM will be 140. I hope you got the idea how we are solving the straightforward method. So I did some mistake in finding the LCM. Anyway, the answer is 19, as we found in the alternate method. Let's do how many problems are left? Okay, quite a few. So let's do problem number 24. So in the straightforward method, we have to first simplify the terms in the LHS and the RHS. So we know that 3 by 4 3 by 4 multiplied by 7x minus 1 is nothing but 21x by 4 minus 3 by 4, and when we multiply and this in the second grouping symbol 2x minus 1 minus x by 2, we can remove the grouping symbol, but we see there is a negative sign before it, so we have to change the sign of all its terms. So 2x becomes minus 2x, and the term 1 minus x by 2 becomes 1 plus 1 minus x by 2, and the RHS is x plus 3 by 2. Okay, now I will this implies 21x by 4 minus 3 by 4, this is minus 2x, and 1 minus x by 2, I know it is half, and minus x by 2, and the right hand side we have x plus 3 by 2. Now I will bring all the x terms to the left hand side and all the constant terms to the right hand side, and this becomes 21x by 4 minus 2x minus x by 2 minus x equals I will bring all the constant terms to the right hand side, that is 3 by 2 plus 3 by 4 minus of half. Okay, now I will have to add up all the x terms in the LHS and add up all the constant terms in the RHS. So this becomes 21 by 4 minus 2 minus half minus 1 x equals 3 by 2 plus 3 by 4 minus half. We have to do the addition of these rational numbers, so the LCM will be 4, so this becomes 6 plus 6 minus 2 divided by 4. This is not 6, this will be 3. So 6 plus 3 minus 2. Okay, now this implies we have to do the, now this is nothing but minus 2 minus half minus 3. So minus 2 minus 1 becomes minus 3. So I can, this is minus 3 and I can remove the minus 1. So now we have to find this. This is nothing but 21 minus 12 minus 2 divided by 4 x equals to 6 plus 3 minus 2 9, 7 by 4. Now this implies 21 minus 12 minus 2. So 21 minus 14 is 7 by 4. 7 by 4 x equals to 7 by 4. This implies x equals to 7 by 4 multiplied by 4 by 7, which is 1. 1 is the answer. Okay, this was the straightforward method. Now since we see there are terms of the form rational in the rational form or fraction form, that is 3 by 4 the first term, not the term, but the first expression 3 by 4 to 7x minus 1, and also we see 1 minus x by 2 and the 3 by 2 in the RHS. So we will take the LCM of all the denominators. So LCM of 4, 2 and 2 is 4. So multiplying by 4 to both sides, we get, when we multiply, we get 3 by 4 7x minus 1 minus 2x minus 1 minus x by 2 equals 4 into x plus 3 by 2. Now if we do the product and simplify the LHS, it is 4 into 3 by 4 into 7x minus 1 becomes 3 into 7x minus 1, and we have minus 4 2x minus 1 minus x by 2 equals, if we do the product on the right hand side, we have 4x plus 6. Now we have to simplify further the LHS. It is 21x minus 3, and we have minus 8x plus 4 into not 4 2 into 1 minus x equals 4x plus 6. In this method, we have to do the product of algebraic expressions very carefully. So we have this. Now we will bring all the x terms to the left hand side and all the constant terms to the right hand side. Okay, we have to do one more simplification, that is do the product of 2 into 1 minus x. So this becomes 21x minus 3 minus 8x plus 2 minus 2x equals 4x plus 6. Now if I bring all the x terms to the left hand side and all the constant terms to the right hand side, it becomes 21x minus 8x minus 2x minus 4x equals 6 plus 3 and minus 2. This implies, let me make a borderline. Okay, so this implies, if I add up all the terms, x terms in the left hand side, it becomes 21x minus 8x minus 2x, that is 21x minus 10x, that is 11x and minus 4x, sorry, 11x. So 21x minus 8x minus 2x minus 4x, it is 21x minus 14x, that is 7x. And on the right hand side also we are getting 9 minus 2, that is x. This implies x equals 7 by 7 equals 1 is the answer. So I hope your, even though my solution is looking very clumsy, I am sorry for that, but I hope you are getting the idea how we are applying the concept of transposition of terms and simplifying the given equation terms of the given equation, doing the products of the algebraic equations and transforming all the variable terms to the left hand side and transforming all the constant terms to the right hand side, and then adding up all the variables terms in the left hand side and adding up all the constant terms in the right hand side, and finally we are getting the form k1x equals to k2, and from there we get x equals to k2 by k1. So this is the basic fundamental concept. Now for equation where you have some terms in the rational form or fraction form, like in the example 24 we have 3 by 2 or 3 by 4 into 7x by 1, in those cases you can take the LCM of all the denominators and multiply both the LHS and RHS with that LCM, and then you will get the equation in a form where all the variables will have coefficient integers and all the constant terms will also be integers. Let's see solve now. This question number 27 is where the coefficient of variable is a decimal. Now it has a decimal. Also we see there is a term x by 3 which is a kind of fraction. Now how to solve this kind of problem equation? So the way I will solve it is that I see 0.5x in the LHS and 0.25x in the RHS. So I will bring the 0.25x from RHS to LHS, and this will be 0.5x plus x by 3 minus 0.25x equals 7. Now I will add up the 0.5x and minus 0.25x. I will do this first, and I will leave the x by 3 as it is, and this is becomes equation becomes this. Now if I do 0.5x minus 0.25x, it is 0.25x, and we have plus x by 3 by equals 7. Now 0.25 is nothing but 25 by 100. So this is 25x by 100, and where we have x by 3 equals 7. Now 25 by 100 is nothing but x by 4, 1 by 4. So x by 4 plus x by 3 equals 7. Now I will add up the x terms. This is nothing but 7x by 12 equals 7. This implies x equals 7 divided by 7 by 12, which is nothing but 7 multiplied by reciprocal of 7 by 12, that is 12 by 7, and this is 12. So 12 is the answer. Now in some cases, in some equation where you have decimal numbers as constants or the coefficient of the variable terms as decimal numbers, it is often convenient if you multiply both the LHS and the RHS with the power of 10, and that power will be the maximum decimal places of the decimal numbers, either in the both considering the constant terms and the coefficient of the x terms. For example, in this example 27, I can see the decimal numbers are 0.25, the 0.25. I mean the decimal coefficient of the variable of the coefficient of the terms of variable terms having decimal coefficient are 0.5 and 0.25. So I see the maximum decimal places is 2, which is in the case of 0.25. So I will multiply with 100. 100 is 10 to the power 2. So 100 to both LHS and RHS. That will make even if I multiply for this example, even if I multiply 100 to both LHS and RHS, the x by 3 term will not make things easy. It will still become 100 by 3x, which is still not a that term, the coefficient 100 by 3 is not an integer. So by multiplying by 100 in this equation to both sides, it will not make all the terms variable terms having integer coefficient and as well as the constant terms as integers. For this example it will not help, but for other examples, let's say for this examples 28, I can see that some constant terms are decimals like 0.8, and also you always first simplify any products. So this I know is 0.8 this is nothing but well, okay, Well, it doesn't matter. I mean, I was thinking if you would first do the product, that is 0.18 into 5x minus 0.18 into 4 equals 0.5x plus 0.8. If you do this, or if you, now we see that the decimal numbers are 0.8, 0.5 and 0.18, and the maximal decimal places is 2 because of the factor 0.18 in the left hand side. So I would like to multiply both sides with 10 to the power 2, that is 100. Now will I multiply by 100 first, or will I simplify the product, do the products and then multiply with 100? I think in both the cases the time taken will be same, and the effort in doing the multiplication required to do the multiplication will be the same. So it doesn't matter if you do first multiply by 100 to both sides, or if you simplify the given equation, I mean you simplify the products and you separate out the variable terms and the constant terms, and then you multiply it by 100 or whatever powers of 10 that is required. In both the cases it will be the same. So anyway, so I have simplified this equation in this form, and now I would like to multiply multiplying by 100 because the maximal decimal places of all the decimal numbers, that by decimal numbers I mean the decimal constants or the decimal coefficient of the variable terms. Multiplying by 100 to both sides becomes, if you multiply 100 to both sides, this is nothing 100.18 into 5x minus 0.18 into 4 equals 100 multiplied with the RHS, that is 0.5x plus 0.8. Now if I do the product of 100 with LHS, so the 0.18 will become 18. So this will become 18 into 5x minus 18 into 4. So I got rid of the decimal part, equals the right hand side will become 50x plus 80. 50x plus 80. So now 18 into 5 is 90x minus 18 into 4 is 72 equals 50x plus 80. Now I will bring all the x terms to the left hand side and all the constant terms to the right hand side, and that becomes 90x minus 50x equals 80 plus 72. And after adding all the terms in the left hand side and all the terms to the right hand side, it becomes 40x equals 152. This implies x equals to 152 by 40. Let me see if I did the multiplications correctly or not. So it is 0.18 5x minus 0.18 into 4, okay, equals 0.5x plus 0.8, okay. Multiplying both sides by 100, we get 100 into this equals to 100 into the RHS. The RHS becomes 18 into 5x minus 18 into 4 equals 50x plus 80, okay. Now 18 into 5 is 90x minus 72 equals 50x plus 80. It is fine. This becomes 90x minus 50x equals 80 plus 72. So 40x equals to 152 2 and x equals to 152 by 40. Okay, looks fine to me. Now if you reduce this rational number further, we get it divides by 4 10 and for 3 12 8 8. Okay, it then again divide by 2 and it becomes 19 by 5. This is the answer, x equals to 19 by 5. Mm, 19 by 5. Okay. Okay, let's do this another problem with decimal numbers, and the coefficient of x is also decimal. Now in this example we see all the decimal numbers, that is the decimal constants, and the coefficient of the variable terms are all having decimal places of 1. So I would like to multiply you can multiply. Now if you are comfortable in doing the addition and subtraction of decimal numbers, then you can do in a straightforward way. For this straightforward way, meaning for this problem, let's say if I proceed in a straightforward way, I will first open the grouping symbol, and this will become 0.5x minus 0.8 plus 0.2x equals 0.2 minus 0.3x. Then I will bring all the x terms to the left hand side, on the constant terms to the right hand side. It becomes 0.5x plus 0.2x plus 0.3x equals 0.2 plus 0.8. Now if I add up all the terms in the left hand side and the terms in the right hand side, I get 0.5 plus 0.2 plus 0.3x equals 0.2 plus 0.8 is 1. Also 0.5 plus 0.2 plus 0.3 is 1. So 1 into x equals 1. This implies x equals 1. So I think this is the best way to solve it. Instead of for this problem, I was thinking to multiply both the right hand side and the left hand side by 10, because all the decimal numbers have the decimal places of 1. So if I multiply by 10 both sides, then we can get rid of decimal numbers, and all the constant terms and the coefficient of x will become integer. And in that case we can only deal with addition and subtraction of integers. But for this particular problem, even without multiplying by 10 to both sides in the standard way, straightforward way, it was not that difficult. It was quite simple. Okay, let's see question number 32. This is the last problem. Now this problem is a little different one. You see that the LHS 2x plus 5 by 3x plus 4 is in the rational form. But the denominator is in the denominator also it has a variable. In the previous problems we saw that the terms that are in the rational form, the denominators were some constant. So for 24 you see 3 by 2 is a denominator, 2 is a constant. 3 by 4, the denominator 4 is a constant, and 1 minus x by 2, the denominator 2 is a constant. But in this problem we see that the denominator also has a variable. But the concept also works similarly for this kind of problem, meaning I will like to, since the only term that has a denominator that is in the form rational form, the denominator is 3x plus 4, I will multiply both the LHS and RHS by 3x plus 4. You may argue that we can only do that when we can multiply an equation with the same non-zero number to both RHS and LHS. And what is the guarantee that 3x plus 4 will not be equal to 0? It is guaranteed, because if it was 0, then 2x plus 5 divided by 3x plus 4, that itself would be undefined, would not be possible. So it is 3x plus 4 will never be 0. So we can always multiply the LHS and RHS by 3x plus 4. So multiplying by 3x plus 4 to both sides. 3x plus 4 will eventually be a number. So the rule says that in an equation you can multiply both the LHS and RHS with a non-zero number. Now that number usually is a constant number, but it also works for that number. It can also have a variable, because eventually we know that an linear equation in one variable, the solution is only one. We will have only one solution, and that solution, whatever the solution will be for x in this problem, that value of x, that solution will never make 3x plus 4 equals to 0. So we can always in this kind of problem, linear equation in one variable, in this kind of problem, we can always multiply by 3x plus 4 to both sides, and we get so the LHS becomes 2x plus, okay, let me do it. This becomes 3x plus 4. We are multiplying both the LHS and the RHS by 3x plus 4. So this implies, if we do the product in the left hand side, 3x plus 4 will cancel out. This becomes 2x plus 5, and the RHS becomes 9x plus 12. Now if we bring all the x terms to the left hand side and all the constant terms to the right hand side, this becomes 2x minus 9x equals 12 minus 5. This implies minus 7x. If I add up all the terms in the left hand side and all the terms to the right hand side, this becomes 7. This implies x equals 7 divided by minus 7. This is minus 1. So this is the answer. So this video was a little long. It took I had to solve quite a few problems using two methods. I hope you understood the straightforward method and the alternate method. The alternate method is for those equation where you have some terms in the rational in the rational form, like for example 24, 3 by 2, 3 by 4. You just find the LCM of all the denominators of those rational terms and multiply both the LHS and RHS with that LCM. And also for equation having decimal numbers as constant, or decimal numbers as constant, or the coefficient of the variables as decimals, you can multiply both the LHS and the RHS by a power of 10, and that power will be the maximum decimal places of the of all the decimal numbers, which could be a constant term or as a coefficient of the variable x. And the very basic concepts like transposing terms from LHS to RHS and RHS to LHS with the change of sign, and bringing all the x terms to the left hand side, bringing all the constant terms to the right hand side, and finally solving the equation k1x equals to k2, where x will be k2 by k1. These are the basic concepts for solving a linear equation in one variable. I hope this video was beneficial, and solving the problems from exercise 7a will give you a good idea of how to solve a linear equation in one variable using all the rules and the transposition. So thanks for watching, and if this video was beneficial, then please like it, share it with your friends, and also if you are not yet subscribed and if you are watching my videos regularly, then please support me by subscribing to my channel and also please do not forget to press the bell icon so that you will be notified by my future videos. So in the next video, that is part 3, I will discuss about the word problems, that is how word problems is transformed into solving a linear equation in one variable. We will solve some problems, and then we will discuss those problems, and we will solve some problems from exercise 7b. So thanks for watching, and until the next video, take care and bye.